Hi, it's Matthew Reid here from howtorepairpendulumclocks.co.uk. A couple of weeks ago I had an English early 19th century long case clock in the shop, and as is sometimes the case with these clocks, the lubrication in the back centre wheel pivot appears to have failed, and the clock has continued to be operated and the pivot has worn significantly. In this case, I decided to repivot the wheel, and I thought it would be useful to show you a video of how I made the drill. The wheel we're going to use for this demonstration is from a 20th century mantle clock. And as you can see, the pivot diameter is about 0.8 of a millimetre. Before I make the steel drill, I'm going to demonstrate the angles by making a drill out of a piece of wood, which may seem unusual, but it's a really good way to get a feel for the geometry of the work. So the first thing to do is to turn a cone on the end of the piece of wood. If we look at a commercial twist drill, that cone included angle is about 118 degrees. On our drill, I'm going to make it about 130 degrees. It's not critical, so the point is a bit wider and therefore hopefully a little bit stronger. So here's our piece of wood set up in the lathe. It's convenient to have a lathe, but it's not essential for making these drills. You can file them by holding the material in a pin vise and filing onto a wooden block. The lathe makes it quicker and maybe a bit more precise. There we have the cone filed on the end of our piece of wood, and the next thing to do is to make some relief immediately behind but not running right up to the edge of the cone. Because this drill has no helix, there's no way for it to easily eject swarf, so this bit of relief has two functions, where one is to allow room for the swarf, and the second function is because if the drill doesn't go in quite straight, we're going to hold the drill by hand, then the edge of the drill doesn't rub on the hole and make it bigger. So again, in the lathe, we turn a bit of relief immediately behind, but not running right up to the cone that we've already made. So that's stage 2. Stage 3 is to file two diametrically opposed flats onto the drill, and we're going to use the indexing mechanism in the lathe. Again, you could do this by hand. So a few strokes of the file on each side, rotate by 180 degrees and do the same. Again, the included angle for these two flats isn't massively critical. The wider that angle is going to change the positive top rate of the tool, but it's a small amount, and hopefully when we see the drill in operation, it'll cut just fine as it is. I think, again, if you're a beginner, try experimenting with slightly different angles here and see how that changes the cutting rate of the drill. So we have our two opposed flats filed on the piece of wood, and the next thing to do is to file on some relief. So this is immediately behind the cutting edge, and we're going to file about 15 degrees in relation to that cutting edge. So we'll put the file on the cutting edge and then tilt it back 15 degrees, remembering, of course, which direction the drill rotates. If you happen to make a mistake here, you'll soon find out when you start to drill. In this case, you could always turn the lathe backwards, of course, but again, the sharper we make the cutting edge, as in the narrower the angle, the quicker the drill might cut, but that cutting edge will be weaker and more likely to wear rapidly as well. So again, there's a compromise to be had here. So there we are, our wooden drill model is done, and it's time to move on to filing the piece of steel. For this I'm going to use blued pivot steel, and I've built this collection up over a number of years. It's still available on internet auction sites and so on. If you can't find blued pivot steel, then you can use silver steel, but I recommend that you harden and anneal the steel first, otherwise it's very sticky to turn. So we just happen to have a piece of steel that's about 0.8 millimeters in diameter, which is a bit of good luck. Now, in this state, blued steel is hardened and tempered back to blue, and it's possible to turn it. In fact, watch balance staffs and things are sometimes turned from this material as it is, but filing is more difficult, so I'm going to anneal the end, and only the end we're going to use, and then harden it after we've filed it. So I anneal by heating to bright orange or bright cherry red, as it is often referred to, and holding that temperature for about 30 seconds before allowing to cool slowly. Be careful here not to overheat the tip of the piece of material. It's easy to burn that, and again I'm only annealing the piece that I need to use. I'm going to use the other end for the pivot. Now, if, like me, you're using the same material to make the drill and to make the pivot, then you need to make the material slightly smaller diameter at the end you're going to make into a drill. Otherwise, any asymmetry in the shape of the drill will mean that it drills oversize and the pivot will be a sloppy fit. So it's far better to have the drill slightly undersized, and if necessary either turn or stone the pivot down slightly so it's a really good fit. So here I'm using a traditional oil stone. You could use a ceramic stone or a diamond plate just to reduce the diameter slightly. So with the work set up in the lathe, you could turn the cone with a graver, but I'm just going to file it. There we are. As I said, about 130 degrees. Next thing to do, just like the wooden model, is to turn the relief immediately behind, but not running right up to the edge of the cone. Then I'm going to file on the two flats. Here I'm protecting the face of the collet with a bit of paper and using the lathe's indexing pulley to rotate the work 180 degrees. And there we are again. Now I'm not going to cut on the relief for the cutting edges right now. I'm going to harden it first because I'm going to stone that relief rather than file it. So to harden, similar operation really. So I'm going to bring the drill, you only really need to harden the end of course, up to bright orange and hold it at that temperature again without overheating for about 30 seconds and then plunge immediately into cold water. I think actually with this really small stock, what I do is to take the flame with the work to the water, because you don't want the cooling to be gentle at all. You want it to be as rapid as possible. So there we have our drill in its hardened state. If the drill was larger or we were using it in a drilling machine, at this point I might temper slightly, bringing the stock of the drill back to straw. But I've actually found with these small diameters, or relatively small diameters, that that's not necessary, and the dead hardness is really good. It means you can drill one pivot out in softish material without having to resharpen. So to generate those two bits of relief on the cutting, away from the cutting edges, I put the drill in a pin chuck with a square collet, which makes rotating 180 degrees really easy. I put the drill upright on the stone, and here I'm using a 1000 grit ceramic stone. You could use a diamond impregnated plate, or you could use a traditional fine oil stone. And I tip the drill across to match the angle of the cone, and then I tip it back about 10 to 15 degrees to generate our cutting relief. Now what's really important here is to only stone or cut away from the cutting edge. Don't push forward into the cutting edge, because it'll inevitably round the cutting edge and the drill won't be sharp enough. And it only takes a few strokes on either side away from the cutting edge to generate a sharp drill. So there we are, and now is the moment of truth. So I've made a centre in the end of our arbor using a graver, and normally I'd lubricate the drill at this point with a bit of spit, but to save you that grossness, I'm just going to drill with it dry. As I say, you must lubricate the drill, particularly if you're drilling into a harder arbor than this. And you can see immediately this drill cuts very readily. Keep removing the drill because it has no way of getting rid of the swarf. You can see here the arbor is magnetized. And once you're down to depth, then I stone slightly the piece of material that's going to form the pivot, just to make the end slightly tapered, and it's a really good fit. So I've turned a notch in the material where I think the end of the pivot needs to be. So a little bit of rounding with a pivot file, then some polishing if you want, and we are good to go.